Example 7, solve the differential equation. Okay, so we have dy dx, so the derivative of y with respect to x is equal to 1 over x times the natural log of x. So, to find the differential equation, we are going to... Okay, first thing I'm going to do, I'm going to write it as a differential. So dy equals 1 over x times the natural log of x dx. Next, I'm going to take the integral of each of these differentials. Alright, we know the derivative of 1 with respect to dy is going to be y plus c sub 1. And this one, we're going to let u equal the natural log of x. So, du equals 1 over x dx. 1 over x dx, that's my du. So I'll make this 1 over du, and the natural log of x, I said that's equal to u. Now I can find the antiderivative of this, which would be the natural log of the absolute value of u plus c sub 2, where we can combine these, a constant and a constant. Whether you add or subtract those together, it's still going to be a constant on this side. Y equals the natural log of the absolute value of the natural log of x plus c. Okay. Let's look at the next one. Alright, for this one, we're going to find the integral of cosecant x dx. So this one we have to do a trick. We have to multiply this by 1. So we're going to take cosecant of x and then multiply this by cosecant of x plus cotangent of x all over cosecant of x plus cotangent of x dx. This is the same thing as 1. So this is going to equal cosecant squared of x plus cosecant of x cotangent of x all over cosecant of x plus cotangent of x dx. Then we're going to let u equal the denominator, cosecant of x plus cotangent of x. So the derivative of u is going to equal negative cosecant x cotangent x minus cosecant squared of x dx. And here we can factor out a negative 1, leaving me with cosecant x cotangent x plus cosecant squared x dx. Now this is all of this. I need a negative 1, so I'll put a negative 1 here and put a negative 1 out in front to balance it out. So now all of this, well, negative 1 is going to be 1 over du. This is going to be u. And we know the antiderivative here is going to be the natural log of u plus c, where u is cosecant of x plus cotangent of x plus c. All right, example 10. we have the integral from 0 to pi over 4 of the square root of 1 plus tangent squared of x dx. So for this one, I'm going to try to use a trig identity. So you can get many other trig identities from the Pythagorean identity. Okay, and I want the one that involves tangent squared of x. So here what I'm going to do, I'm going to divide through here by cosine squared of x. So this would become tangent squared x plus 1 equals secant squared of x, which means I can substitute this for secant squared of x. And I know that the square root of a square, those are inverse functions, so they undo each other. So then I'm just going to have secant x dx. And now this problem becomes like the last problem, where I'm going to use a special one. I'm going to multiply secant of x by secant x plus tangent x all over secant x plus tangent x dx. Where if I multiply through here, this is going to be secant squared x plus secant x tangent x all over secant x plus tangent x dx. Then I'm going to let the denominator equal u, then take the derivative of u with respect to x. So the derivative of secant of x is going to be secant x tangent of x, and the derivative of tangent of x is going to be secant squared of x dx, which this will become du. The denominator will be u. Now the other thing I have to do, I need to convert limits of integration. So when x equals 0, u equals secant of 0 plus tangent of 0. So tangent of 0 is 0. Secant of 0 is 1. So that's going to be 1. And let's see, when x equals pi fourths, u equals secant pi over 4 plus tangent pi over 4. So let's see, tangent is going to be, tangent of 45 degrees is going to be 1. Secant, let's see, secant of 45 degrees, or pi over 4, secant is going to be equal to the hypotenuse over the adjacent. So this is going to be 2 over the square root of 2. You can rationalize the denominator. This would be 2 over the square root of 2 over 2. So this is going to be radical 2. So now I got the limits of integration from 1 to the square root of 2 plus 2. all of this is 1 du over u. Antiderivative would be the natural log of the absolute value of u. We're going to evaluate this from 1 to the square root of 2 plus 1. So this is going to be equal to the natural log of the square root of 2 plus 1 minus the natural log of the absolute value of 1. We know that is 0, so my answer is going to be the natural log of the absolute value, the square root of 2 plus 1.